All right, hello. We are here to do a walkthrough of practice quiz number 2 for LT number 11 about three-dimensional solids. So this will be our answer key. Let's start up here. First step, draw the other views of the solid. Now the map plan is all about drawing numbers. I like to label my map plan as front so I know which way to orient it. Now what that means is how many cubes do we see in this position in this diagram? In this 3D cube solid, how many cubes do we see in this front left position? Now, this front left position right here means this position right there. Okay. In there, I see 1 cube, so I put 1. Behind it, going backwards this way is the same as going this way. So behind it, I see 1, 2, 3. Cubes don't float. Behind that one, I see 3. Again, this is the back left corner up here. In the row next to it, so this is like row 1, row 2, I move this way 1. There's no cubes here. There are no cubes here. It's blank. So I can either put a 0 or just leave it blank in my map plan. Either one's fine. Behind it, I see there's 1. Behind that, I see 2. Okay. So that is the end of our map plan. Again, it's okay if you want to leave it like this or you want to write zeros. Either one's fine. Now, the front view. Again, that's looking at it from this perspective. How many do I see? If this gets flattened, so it's a 2D perspective, I can't see the depth of the cubes. All I see is how many total cubes high do I see. So in this first column on the left, I'm going to see 3. There are 3 cubes there. How do I know that? I see 1, 2, 3 cubes high. In the second column, right here, I'm going to see 1, 2 cubes. So it's going to look like this. Do I see any in this one? There are no cubes there. Nothing to see. Leave it blank. From the right view. Now, this is from the right view. That means this left one right here corresponds to this spot right here. Okay. What do I see there? I see just 1 block high, 1 cube high. That goes there. Always start from the ground. Always start from the ground. Move to the middle. That's this one right here. And I see 1, 2, 3 high. So I'm going to shade 3 right there. And then the last one on the right, again, this column, I see 1, 2, 3. So my right view looks like that. If I were to flatten this out and just look at it in a 2-dimensional way, looking at this perspective, 1 block high, 1 cube, 3 cubes high, 3 cubes high. 1, 3, 3. All right, that's standard 11.1. Those are our views. Let's move on to standard 11.2. Names and nets. First step, I see 2 circles connected here. We call this a cylinder. When I draw the net for a cylinder, I think about my 2 circle bases, base and base. And if I unwrap this lateral face going around here, it forms a rectangle. Now, we're not worried about being perfectly precise, but we do want to be relatively precise if we can. Okay. That's a cylinder net. For the second one, what do we have here? I see 2 hexagons. 2 hexagons, 2, 3, 4, 5, 6, connected by rectangles. That means I'm working with a hexagonal prism. I know it's a prism because I have 2 congruent polygon bases connected by rectangles. So for a prism, I want to think about drawing 1 base. So I'm going to draw a hexagon. And again, don't worry about being too precise, but we want to be accurate as we can. So there's our hexagon. Now from that, we know there are lateral faces. There's different ways to do this. I'm going to draw 1 net here. These lateral faces are all connected to each other. 3, 2, 3, 4, 5, 6. There are 6 lateral faces. 1, 2, 3, 4, 5, 6, because there are 6 sides of the base. Then I need my other base, my other hexagon. 2, 4, 5, 6. So now I have my 2 hexagon bases and my rectangular 6 lateral faces. There are different ways to draw this net. That's just one. As long as yours works, good to go. Okay. So that is standard 11.2. Let's move on. 11.3, find the volume. Find the volume. So for volume, really what I want to think about here is base area times height. It all starts there. Find the area of the base multiply it by the height. First step, I have a cylinder. My base here is this shape. It's a circle. So I want to find the base area times the height. So what's my base area? Well, it's a circle. So I'm going to go pi times the radius squared times the height. Turns out the radius here is half of 16. So that's the radius. So pi times 8 squared. And my height is 11. Okay, my height is 11. That works out to be 8 squared is 64 times 11 is 704 times pi, if you want to leave it like that, meters cubed. Or you can multiply 704 times pi to get 2,211.68 meters cubed. Either one is fine. Okay, either answer works fine. For the second one, what shape do we have here? We have a rectangular prism. All right. On these ones, you can really decide what the base is. I'm going to choose this down here as my base. So rectangular prism, again, base area times the height. Well, my base area is that rectangle down there, which is 6 times 1. It's the area of that rectangle. The height is the distance between the bases, right there. So this is the height. So 6 times 1 times a height, not of h, of 4. 6 times 1 is 6, times 4 means it's 24 cubic yards. That's our volume for that rectangular prism. Okay, let's move on to standard 11.4. Now on this one, this can get hard. We can easy to lose track of numbers. Get scratch paper, spread your work out as you need it. Okay, don't crunch your work in here. Try to stay organized. That's the biggest thing. Okay. So Daniel was hoping to build and paint a birdhouse with the dimensions listed in the photo to the right, not to the left. Wasn't sure how much paint he would need. What is the volume and surface area given the unpainted entry hole has a radius of 4? So that's got a radius of 4. I know you can't really see it there on the video, but we'll add it in there for our own notes. So I'm going to find the volume first. I think volume is usually a little more straightforward all the time. So for volume, I have a rectangular prism and a triangular prism. So I need to find the volume of a rectangular prism plus the volume of a triangular prism. Well, let's find the volume of the rectangular prism. I'm going to choose my base as the bottom down here. So my base area is going to be 30 times 24. And then the height of my rectangular prism is going to be 18 times 18. And I need to add that to the volume of the triangular prism. Here, my base is going to be this triangle on the end. So the volume of that, well, it's 30 units, 30 centimeters wide by 8 units high. So for a triangle, base times height divided by 2. And I'm going to multiply that base area times the distance between the bases, which is 24. All right. So 30 times 24 times 18 is 12,960. 30 times 8 divided by 2 times 24 is 2,880. Add those two together, and you're going to get 15,840 centimeters cubed. Again, this is the rectangular prism volume. This is the triangular prism volume. Add them together. That's volume. Now, for surface area. Sometimes I like to do this in kind of like 2 parts, okay? So first step is I'm going to find the surface area of the rectangular prism. Okay? So rectangular prism, surface area. So for that, let's see. I've got my base. All right, I've got my base down here. That's going to be 30 times 24. So that's one base. Now I only have one base area. Why? Because the other one's covered up by the roof. So I'm not painting it. I only have one 30 by 24 face. Then I can see there's 2 of these 18 by 24 faces. There's one here and one on the back side. So 18 times 24. And then there's 2 of this face in front. Now this face, I see it's 30. The height here must be 18, the same as there. But what's interesting here, so 30 times 18. Why am I making a mistake? What am I doing? This front face is not the same as the back face, so I can't actually do this. They're different. The back face is 30 times 18, but the front face has this entry hole in it. So I need to account for that. So it's going to be the area of that rectangle minus the area of that circle, pi times 4 squared. Sorry, I got a little crunch there. So again, this is the bottom base right here. This is the two sides, the two lateral faces there and there, 2 times that. 30 times 18 is around the back side. And this one, 30 times 18 minus the area of that hole right there, okay? So what does that work out to be? 30 times 24 is 720. 2 times 18 times 24 is 864. 30 times 18 is 540. And 30 times 18 minus 16 pi is 489.73. Add those all together. 720 plus 864 plus 540 plus 49.73. And we're going to get 2,613.73 square centimeters. What is this? This is the rectangular prism surface area. In addition to that, I need the triangular prism surface area. Now, what do I have here? I can see I've got the two bases here and here. Two bases, front and back. So 2, and the area of each base is 30 times 8 divided by 2. And then what else have I got? I've got these two roof faces here and here. Now, I can see if this is 17, this must also be 17. It's an isosceles triangle. So each of those faces is a rectangle measuring 17 by 24. So 2, 17 times 24. So what does that work out to be? Turns out 30 times 8 divided by 2 times 2 is 240. 17 times 24 times 2 is 816. Add those two together, and you're going to get 1,056. Finally, total surface area is going to equal them added together. So 2,613.73 plus 1,056 should get us 3,669.78. I think that should be 73, huh? Yeah, that should be a 3. I don't know why I wrote 8 there. I got confused. Let's check our work here. 2,613.73. 3,669.73. So again, this says 0.73 square centimeters. So that's the final surface area. The key here with surface area, think through each step one at a time. What surfaces are shown? What surfaces need things taken out of them? What surfaces should we not count? And just go one at a time. Okay? Hope that's helpful. Good luck on your quiz.